Hello, today I'm going to be solving You Are the Teacher week 2. So that includes problem 4 of lesson 3, problem 8 of lesson 4, and problem 8 of lesson 5. So let's get started. So in order to solve this, we must first plug in the x's to the following equations here, or inequalities I should say. So let's start plugging them in. For f, x equals negative 3, we plug it into this equation here. So we get negative 3 plus 1, which we know negative 3's absolute value is 3 because it is 3 points away from 0, plus 1 equals 4. So that's number 1 done. Now f(x) equals 1 equals negative x plus 1, which also equals negative 1 plus 1, which also equals 0. And then lastly, we have f(x) equals 3, which also equals, as we see here, negative 3 plus 1, which equals negative 2. So now the equation or inequality that's left over is x is greater than or equal to 1. In order to solve this, first we must understand that the absolute value of x is going to be the same as the absolute value of x plus 1, except it's going to be 1 point higher on the y. So through our understanding of that, we know that our next equation will be f of b squared plus 1 is also equal to negative b squared plus 1, because whatever b is, even though it's squared, it's always going to be a positive number. And then plus 1, we know that it's going to be bigger than 1. So x is greater than or equal to 1. So since we know that it's bigger than 1, we know that the answer is actually equal to negative b squared. That's the answer. Here we are, lesson 4, problem 8. And to begin with, we must first understand that through graphing this set limit here, we will never reach the point x equals 2. Let's say x equals 2 here. Since we're approaching to positive, we have to go from the left up. And we see here that the farther we go up, the bigger the number gets. Therefore, there is no fixed point for this equation here, because this will keep on arriving to infinity, which is not a fixed number. And this would also apply if we were approaching the limit from the left side, which would make this negative infinity. Because as we see here, let's say we put x, any number that's above 2, so let's do x equals 2.00000001, your number will keep on getting bigger and bigger and bigger, because let's put it into perspective. 2.000000001 minus 2. That would only leave the decimal over, and we can see that that is a really big number. So through this, we understand that there is no limit, because the only place it would get to is infinity, and is not a fixed number. Therefore, there is no limit. Explain why f of x equals x squared minus 2 minus cosine x has 0 in the interval 0, pi. So first, we notice that f of x is continuous because the number doesn't have a set value. So what we can do is we can plug in a and b to the equation. If we plug in 0 into this equation, we'll get 0 minus 2 minus cosine x, which would equal 1, because cosine and 0 equal 1, which would equal negative 3. And if we plug in b, we would get 3.14, which is pi, squared, minus 2, minus negative 1. If we were to do this on a calculator, it would approximately equal 8. So now, we apply the intermediate value theorem, which says that if the interval is close enough and f of x is continuous, there has to exist a 0 between the 2 points. So let me draw it out for you. Let's say a is here, f of a, and let's say b is here, f of b. There has to be some point here in between these 2 points that is 0, which is also equal to k. So since we apply the intermediate value theorem, there exists a k equals 0 between f of 0 and f of pi, because f of c, which is this, hold on, equals k, which also equals 0. And that is the solution.